Hello, this project is titled Priority Based Preemptive Task Scheduler with Dynamic Memory Allocation. This is a mini project done as part of Embedded Systems course for Jan to April 2024 session. So, this scheduler has 7 main tasks and 4 interrupts. So, the definition of the tasks are as follows. Task, let me demonstrate it here. I'll press reset button. So task 0 has the red LED on continuously and count value is incremented on the rightmost 7 segment display. And task 1 will have blue LED on continuously as you can see here, and count value is displayed on the second 7 segment display. And task 3 will have a green LED on continuously and count value will be displayed in the third 7 segment display. Green LED is on as you can see here. Task 4 will have white LED on continuously and a count value is displayed here. White LED is on and this is task 4. And task 5 will send values from TIVA to LTC1661 DAC to generate a sine wave. And when task 4 is executing, the color is magenta, and when task 5 is executing, the color of the LED will be yellow, and when task 6 is executing, color of LED is cyan. So when tasks 5 and 6 are executing, they will request for dynamic memory and they will perform some operations in dynamic memory, and once those operations are done, the dynamic memory allocated will be deallocated, and then the process is repeated all over again. So, and whenever a task gets preempted by other tasks and later when we get back to the same task, they will start from where they left off previously. Now let me show the values of the priorities which are here. Task 0 has priority value 0. So 0 priority value indicates that the task has the highest priority among all the main tasks, followed by task 1 having priority 1. And here we can see that task 6 has priority 6, which means it has the lowest priority among all the tasks. This debug variable task 4 indicates the values which are being sent from TIVA to LTC1661 to generate a wave. And task 5 and 6, debug variables of task 5 and 6 just denote the values which are being incremented in the dynamically allocated memory section. So here I have graphed the debug variable task 4, which indicates the values which are being sent from TIVA to LTC1661 DAC. And here you can see the spikes which denotes the various values which are being sent from the array to LTC1661. Simply put, these spikes indicate that task 4 is being performed. And this flat line that we can see here indicates the fact that task 4 has been preempted by other tasks by the scheduler, right? So let me change the priority of task 4 and give it a high priority value. So I press this key to change the priority values which is associated with all tasks. So now if I press the key again, you can see that the priority levels are changing. If I press the key again, now we see that task 4 has priority value 0, which means now task 4 has the highest priority among all the tasks. And now when task 4 performs, we can see that the spikes have started again, which means that the task 4 has started execution again. And now we see that the number of spikes is more when compared with the number of spikes that we had here. So here we see that there are more spikes, and here we see there are less spikes. So this is task 4 having lower priority, hence lower processor time. This flat line indicates that task 4 was preempted by other tasks, and this more number of spikes indicates that task 4 was being performed with a higher priority and hence more execution time. So this key is used to change the priorities of each task. These two keys are interrupts which are used to print some text on the screen. For example, if I press this key, you can see that the statement inhale, exhale and repeat is being printed. I press it again, once again it is being printed. Press it one more time, it is printed. And now when I press this key, it prints the text. It prints the text that this mini project is a preemptive task scheduler done as part of embedded systems course. If I press it again, once again the statement is printed. If I press it again, once again the statement is printed. And this final key is used to present a snapshot of the dynamic memory usage, which will be demonstrated now. So these 4 keys are the interrupts, and there are 7 main tasks as explained earlier. So now let us see the dynamic memory allocation which is being happen. So when I press this key, it provides me a snapshot of the dynamic memory usage. So I press this key once. So here we see that there is one node in the used block and one node in the free block. These nodes are just the header nodes which are allocated at the beginning. So this is a snapshot of the dynamic memory usage after the initialization step. Once tasks 5 and 6 start executing on dynamic memories, we will see that the sizes or the number of nodes in use blocks and free blocks will be more. So here we see that memory has been allocated to task 5 and task 6. So now let me go ahead and have a look at, press this key and have a look at what my dynamic memory looks like. So once memory was allocated to task 5 and task 6, we see that there are two more nodes in the use blocks. So these two nodes indicate the chunks of memories which was allocated to task 5 and task 6. And now the free block, which was earlier present at 7780, has now been moved to 77844, which is the next available memory location that can be allocated to tasks. So as we keep running the program, the sizes of the used list and the free list will keep growing and reducing in size dynamically as the memory allocated to task 5 and task 6 keeps on changing. So that concludes the demonstration for this mini project. Thank you.